Okay, so right here is bird's eye view of the floor plan, 10 meter by 15 meter, and then it shows like the distance between the shower wall and the wall here is 2.5 meters. This is the three-dimensional 15 meter lengths, 5 meter heights, and then 10 meters from wall to wall. So essentially this is comprised of 4 5 by 5 by 5 cubes. So, well, no, it's a 5 by 5 by 7.5. Okay, in this model. Anyway, so then that requires uh, 4 5-meter sections of L beam, 7 5-meter sections of T beam, 4 15-meter sections of L beam, and 4 10-meter sections of L beam. So that would be the 4, the 1, 2, 3, 4 5-meter sections of L beam, the 1, 2, 3, 4, 5, 6, 7 5-meter sections of T beam, the 1, 2, 3, 4 15-meter sections of L beam, and the 1, 2, 3, 4 10-meter sections of L beam. And then this equation here models something about thickness. Minimum thickness that I could comprise a structure of would be approximately 10 centimeters, and heavier thickness would be approximately 20 centimeters. And so what I want to do is build a curve based on the thickness of the walls that are poured for this structure and the weight. And so given this range, if it was 10 centimeters thick, that would be 0.1 meters times the 700 square meters of surface area of all walls added together, and that would yield 70 cubic meters of mix needed. That's the volume of the concrete needed, okay? Approximately, all right, because of course there's absences where the rebar is in the frame. This is for a rebar frame that's 1 meter on square. So the frame is a meter square throughout. Or if the walls were 20 centimeters thick, which is a little bit more than 7 inches thick, almost about 8 inches thick or so, then that would be 0.2 meters times the 700 square meters to yield 140 cubic meters of material. So that's if I had a cube of concrete that measured 1 meter on each side. If I had 140 of those, that would be equivalent to the amount of material needed to pour all of these walls 20 centimeters thick. So I think the number I want to choose is 100 cubic meters of material, and the thickness that satisfies that result is 14.2857 centimeters, which is just a little bit less than 7 inches. It's 5.5 inches or something like that. It's approximately 5.5 inches, the thickness of the walls throughout. So that means we would have to use a certain gauge rebar if we built that. So that would be our next determination, is the diameter of the rebar, and if we could use a lighter weight rebar. And like I explained about using L beams and T beams, that's what our rebar is going to weld into. So, we'll have the floor laid out, L beams all around the edges of the floor, and then rebar welded in vertically. Almost like loomed, I think we could do. But anyway, and then that's kind of an overview of the materials needed. So I would say 100 cubic meters, probably by 110, enough to mix 110 on the concrete mix. And then like I already indicated the length 550 meters of rebar total needed, with minimum section lengths of 5 meters. So we'd have to order it. I think we would probably order if they have 15 meter solid pieces of rebar. If they have that 15 meters, that'd be something. How many 15 meter pieces would we use, for one? And that would be just less than 40. Just less than 40 of those. If we could get 15 meter pieces of rebar, we'd order 40 of those for an individual unit. And then there would be some extra afterwards. But yeah, 15 goes into 550. 40 times 15 is 600, so 35 of those would be plenty. If we had ordered 35 15-meter sections, that would be enough to build an individual unit. But yeah. And then there's the commode and the pipes for those fixtures and other stuff. But I'm going to get some estimates together